Hi.
Shrin's here with me, so then
Okay.
we don't take up more Wi-Fi.
All right. That's good. I won't mark her absent. Morning.
Mr. Sotelo, how many assignments have we had since we started e-learning?
One a day, so 4.
We've had 4 assignments.
Yeah.
Which ones are they?
1 through 4.
And
There's
then
one.
Inverse functions, there's 2 of them.
Well, there's a video and then an assignment for each one.
Oh, okay. All right.
So the one with like the globe picture is a link to a video. It's the same stuff that I go over in class, but in case you're not wanting to watch the video or you want to do it live and ask questions, I pretty much do the same thing.
So today we're doing the inverse functions.
Yep. I put the videos there in case people wanted to work ahead, and some people did. If you haven't done the old ones, you do have late passes. So if the assignment becomes invisible on the wall, you can go to the gradebook and you should be able to see the assignment. The late passes will extend the due date for you, but I think the later you go, the more late passes it'll take. So you don't want to wait too long. I'm still missing a couple people. 3. I don't know. I didn't see attendance today. I don't think it's out yet. Okay, hopefully they join. I can get started then. So if you just popped in, I was saying in the classroom kind of wall, you have that block that says first 2 weeks. You have, a video, an assignment, a video, an assignment, where I go over the stuff in the assignment. But I've been going through that same stuff in class. So if you can't see the older assignments from last week that were due last Friday, I think, then you just go to your grade book and you should be able to see the assignments, and then you should be able to access them with a late pass still. This week's assignments are due tonight at 8. So but if you still had late passes, you could use those. But I was saying that the later you go to use the late passes, it'll eat up more of your late passes. So don't wait too long. But you have that option. So last class we went over composition of functions. That was kind of where you applied one function and you applied the other function. This week is kind of related to that, or today, where we're going to go over inverse function. I've been addicted to these dumb little math memes. I found a page, and one had inverse functions on it, so I shared that with you. Maybe you'll enjoy it. But I will start going over that now, and then you guys will have time to work on that today. And I'll stay in the meet like regular. So if you have questions on it, you can ask me. Oh, I gotta present. And then you guys get a long weekend. You get Friday off and Monday. So make sure to enjoy it. Okay. All right. So with last class, we went over function compositions. So that was like where if I had a function, f of x is equal to x plus 2, and then I had another function, let's say g of x is x plus 1. So I have these two functions. F takes your input, x, and it increases it by 2. So if I plugged in 5, it would give me 7. If I plugged in 10, it would give me 12. G just adds 1. So if I put in 5, it would give me 6. If I put in 100, it would give me 101. So if I performed a composition, which you could write like this, F little circle, empty circle, G of x, that stood for first applying G onto the input and getting your output, and then taking that output and feeding that into the function f. So I would write, since I do f last, I would kind of write f, but instead of x, and I leave it blank. So instead of x plus 2, I'll just do parentheses plus 2. And then in the parentheses, I would put what the function g is. So this is like f, something plus 2, but g goes inside of that. So I put x plus 1 in there. So g got fed into f, and it went where x was. Is that okay so far? All right, so if I just simplify that, I get, for my composition function, x plus 3, which makes sense. If g increases a number by 1 and f increases it by 2, when I apply them one right after the other, it ultimately is the same as taking the input and adding 3 to it. So that's the composition function. It's kind of like the combined effect. Now, if I had a different function, let's say my function was x minus 2, then that would actually be the inverse function of f. If f adds 2 to the input, the inverse function would take 2 away. The idea of an inverse function is that it undoes whatever the function does. And we just signify it with this, you use the same letter f, but you put a little -1 superscript to indicate that this is the inverse function of f. So whatever f does to the input, if I apply f and it does something to the input, and then I apply the inverse of f, it'll undo that and give me back x, just plain x. It gives me back the input. So whatever f did to the input, inverse of f undoes it and takes you back to where you started. So if I perform the composition with that, f, and I'll do f minus 1 composed with f of x. That's the same as applying f minus 1 after you apply f. If they're inverse functions, you can test to see if two functions are the inverses of one another. If when you make the composition, you get back x, then that means altogether they did nothing. What one did, the other undid. So if I do this, f prime is x minus 2. So that happens last, but what goes in that parenthesis where x was should go f. So I'm going to put x plus 2 in there. And if I simplify that, plus 2 minus 2, that's 0. So I just get x back. And that's how I know that I have two functions which are inverses of each other, because they have no net effect when I apply them both. Does that make sense? Okay. So how would you find the inverse function? Let's say I have a number. Let's say I have a function. F of x equals 2x squared plus 3. So whatever I do to x, I get an input number, x, and whatever that is, I'm going to square it, add 2, I'll write that out, square number, times 2 plus 3. And those are my steps. So that gives me my function. That's what it does to any input. Now, in order to have an inverse function, it should do the opposite operations in the opposite order. So what the inverse function should do is subtract 3, divide by 2, and then lastly, square root. And that will undo whatever was done. So let's say I started with the number 10. So if I had 10, I'll do a different color here. I have 10. My first step is to square it, so I get to 100. Then I double it, and then I add 3. So now if I have the inverse function, if I give it 203 as the input, if I subtract 3, I'll be at 200. If I divide by 2, I'll be at 100. And if I take the square root, I'll be back to 10. So the inverse function should do the opposite operations in the opposite order. So I already know that my inverse function should be x minus 3. That should happen. So subtract 3, then divide by 2 after I subtract 3, and then square root that. So that's one way you could kind of figure it out, what the inverse function is. Another way is to take this function that you have and think of it as the same as y equals 2x squared plus 3. And that's your original function. F of x you can think of as y. You can always, they're kind of interchangeable. This notation is just nice because you can talk about f at 1 or f at -3. You're able to show different inputs easily. But it's the same as y. It represents the output after you plug something in, which is the y coordinate. So you can think of that as y equals 2x squared plus 3. The way you would find the inverse function, another way you could find it, is swap x and y, wherever you see them in your function. So instead of y equals 2x squared plus 3, I'm going to say x equals 2y squared plus 3. And to get my inverse function, after I make that swap of inputs and outputs, you just have to solve for y. So get y by itself, and then that's your inverse function. So to get y by itself, I've got to subtract 3 on both sides. So I get x minus 3 is equal to 2y squared. I'll have to divide 2, trying to get y by itself. There we go. And then finally, I can square root both sides to get just y by itself. And then I see that y is equal to the square root of, because the square root and the square undo each other. So that should give me x minus 3 over 2 square root. And that's how you would get your inverse function in another way. Is that okay? You guys follow that? So again, a couple strategies. You could sort of think of the order of operations with your function, sort of write it out. What do I have to do and in what order? And then you could reverse the operations and the order in which you do them. That could do it. Or you could just swap the x and y in your function and then solve for y. That's another way to do it. Okay, a couple other things to point out about inverse functions. If I know that I have a function and they give me a table, and I know at different numbers, let's say it's like 6, 10, 14, 18. Well, I'm not picking the best. I'm going to do simple. I'm just going to do one apart. So I'm going to write that a little differently. I'll do 4, 3, 2, 1, 0, minus 1. So those are my inputs on the left, and then the function turns those into the numbers on the right. Those are the outputs. If they give me that, I know that if I have a point 0,4, that means the inverse function has to have a point 40. Because if I take the output and I make it the input of the other one, its output should be my original input. So the inverse function will take these numbers and turn them into the other ones. That way, if I put 0 into f, I get 4. And then if I put 4 into f negative 1, I get back to 0. It undoes it. It reverses the mapping. So that's one thing to keep in mind. If you know that there's a point on the function, that's like 1, 3, then you know that on the inverse functions graph, you're going to have 3, 1. You know that if you flip the x and y, that gives you all the points of the inverse function. You just got to flip the inputs and outputs. So what was an input for f? It gets an output. Now you just reverse that. You treat the output as the input, and it gives you back the original input as the output. So it just flips that x and y. Is that okay? All right. One thing to note about flipping x and y, on a graph, you can kind of tell visually if two things are inverse functions to each other, is if I have a graph, this is y, and this is x. So what the inverse function does is it takes that graph and it kind of treats it, it's kind of as though this becomes y and this becomes x. If you could rearrange your graph in that way, oh, just got my foot stuck in my chair. Then how would you do that? So if I take, let me try to take a piece of paper. Oh, let me show you myself, I guess. Okay. Try to do the same on this side. Okay, so I've got a piece of paper. I just got like a little coordinate system. And on the other side, I kind of did the, like if you were looking behind it. So here, X goes to, over here. But when I flip it, it goes that way. So it's kind of like, if it were transparent, that'd be a little bit better. But here's an XY coordinate system. So if that's my normal graph, so let me draw a picture, actually. Let me do a function. So I'm going to do a kind of a parabola. That's my parabola. To think about what the inverse function would look like, you have to get the y-axis going that way and the x-axis going up. So what you would have to do is kind of rotate it and then tilt it 90 degrees. And that's what the graph of your inverse function will look like. So the inverse function of this thing will look like that. It kind of flips the x and y's. So that's one thing to keep in mind. You can always kind of visualize in your head what this thing ought to look like by thinking of that transformation where you sort of rotate it and turn it 90 degrees. I just got ink all over my desk. Whoops. It's not good. So the graphs, they always, if you flip the x and y, there are always reflections around this axis, this y equals x line. So if I've got some sort of curve that does like that, that's my function. That's f. So my f prime would be mirrored. So however distant this is, I'm going to be just as distant over here. If this is that distance, then I got to be just as distant here. That's that distance. I got to be just as distant here. And so my graph is going to look like this. And then this will, oops, to here. So it's always a mirror image across this sort of y equals x line. When you flip the x and y's, the graphs will always look like that. So one graph that you'll come to know in the future, if you don't already know it, from Algebra 1, is an exponential graph. And we will find that the logarithm, which is the inverse of that function, looks like this. They're mirror imaged across this line. And those are inverse. Inverse functions always look like that compared to the original function. They're mirrored across that line. So that's some stuff to know. If you had the point 0, 1, you would have the point 1, 0. If you had the point 1, 2, you'd have the point 2, 1. You always know that that's going to be the case with inverse functions. So that's that pretty much covers it, I think. That's kind of tells you how the graphs look, how you can make one graph into the other, just flip the x and y coordinates of all the points. It will look like it's mirrored across that diagonal line. And if you have a table and it shows you inputs to outputs for the function, those will be flipped for the inverse function. So in one of them, I think one of them, they give you tables and you got to fill in the blanks. So you just got to know that if the regular function has an x and that gives you a certain output, that's going to be flipped for the inverse function. So if you have like the input's 1 and the output's 4, and then on the other graph, it says, well, what inputs gives you 1 for the inverse function? Well, that'd have to be a 4, because if over here it was 1, 4, on the inverse is going to be 4, 1. So you'll have to sort of like fill in the missing information with some tables like that. And again, if you have an expression for your function, flip the x and y, and then isolate y. That's how you can find your inverse function. Okay? Any questions? All right. Well, you guys spend some time working on this. You have some class time here to do some work. You can stay in here if you'd like, or you can pop out, and before 10:30 you can pop back in if you have questions. I will be here. But that's the lesson, and you also have the video. Otherwise, you guys enjoy your weekend, and I will see you in person on, what is that, Wednesday? Yeah, you too. Thank you.